So we have a more glorified version of the slider crank mechanism that we did last week, and that is this, okay? So if you look at the individual parts, there is a piston, there is a crank that I would like to make it look like that. Here is my connecting rod or the coupler, and this whole thing that you see here, so that little piece plus these little two carry-ons are the track, okay? Now, I also have a pin here that I will put through that hole, through that connecting rod, coming from the other side, and basically holds the pin and the connecting, or the piston and connecting rod together. Now, this for mechanism purposes, for let me see that, for kinematics purposes, this is not necessary, but I will throw it in here so that you can see that there will be a complication that we have to fix. In other words, I could have done this problem without this pin. However, I would like to include the pin to see what problem we're going to run into, and then we worry about the second problem later on. Are there any questions? In my opinion, this is probably the most involved assembly that you are doing in this course. And, you know, yeah, that's pretty much it. It's still very simple, but I'll show you the steps. All the steps are going to be shown. So let's start with the product file. New product. Say OK. Immediately save it. I don't want to be here. I want to go to assembly design, as you can see. So file save management, save as, desktop, new folder. I'll call it one single cylinder. It's going to be on the top. You don't have to fool around, look for it. All right. Let's start with the piston. So I'm not going to worry about dimensions whatsoever. So insert new part in there, and this is going to be my piston. Right click, properties, piston, and piston. Okay, let's make it. Double click on this. You go into part design. On a convenient plane, on that vertical plane, I will sketch. Okay, something that looks like that piston. So I'm going to draw a geometry like this. And I'm sure you know what these things are. These are for the piston ring that you put metal gasket there so that, you know, the thing does not leak or whatever. Okay. Now, I would like to I can make the top flat, but because of the thing that I have here, I'll make the top a little bit curved. So let me draw a line here first of all. You'll see what that line is for in a second. Okay, and I'm going to make this line into a construction line right there, and then I'm going to do an arc. Where's that circle? Arc. For example, from this point, actually, just a second. So let me do a spline. How about the spline? So going for example, where's the spline here? Right? Is this a spline? Yeah. From this point to, come on. This point to that point. Okay, I don't want this thing to be a construction. It's going to be a curve. And I want this thing to be tangent to that, okay? So that line, that construction line, control that curve. Let's make them tangent to each other. All right. And okay, this is too high, so let me move it a little bit up. That's fine. Okay, and I'm going to close this because I want to shaft that to get the piston. Exit. Notice that I made that construction line because I don't want it to participate in my you know, creation of the piston. So shaft, that sketch about the z-axis, 360 degrees, and there we are. Okay. Now on that plane, on one of these planes, so let me put this thing in isometric view. On this plane, I will sketch a little rectangle because I want to have a cutout here to be able to this. See that? I want this cutout here. Okay. So exit, pocket in both directions. More. There. Okay. And I want this thing on the other side too. So mirror that. So where is the mirror? Let's see now. This is this mirror. Mirror that pocket with respect to that plane. There we are. We have it on both sides now. So on that face, I will sketch a little hole because that hole is going to carry the pin. So let's make it a circle. Again, dimensions I'm totally ignoring here. Exit and make a pocket all the way through. All the way to the last. Is that the last? There, you can see it, see through it. And I'm going to remove material from inside of this. And that can be done by the shelling operation. If you look at the toolbars, one of them says dress up features. Okay, and there's one that says here shell. So you take, it says, let's read this thing carefully. Face to remove is this. And the amount of removal, so let's default inside thickness. Let's make this thing 0.1, see how it looks like. This is good, except that I didn't want this piece either. So let's go ahead, double click on the shell. And also as faces to remove, let's put this face also. And then we say, okay, there we are. There's my piston. Done. Let's go ahead. Save everything.
Okay. Can you repeat this step, please?
Shelling operation?
Yes, please.
Okay, so you go to part design. It's in part design. Where's that piston? Under dress up feature, there is this icon here which says shell. And when you do that, it's going to ask you what faces to keep, what faces to remove. So I remove that top face and I remove that hole. And it says how much wall thickness you want to give it. And I put 0.1. And then that's it. Okay. So that's what it was.
And how does it know when to stop shelling? Like,
it goes until it reaches the end on the other side. I mean, basically, there's something wrong here, though. Wait a minute. I've got to find out what this thing is. I don't think I went probably far enough. It just removes the material, leaves the 0.1 until it reaches the end. Yeah.
Okay, thank you.
Yeah, there's something wrong here. I don't know. What is this? Maybe it didn't go all the way through. Okay, I should have said up to something. When I did the pocket here, I'm not sure. Hang in there. Pocket to the last, and that's okay. There's no problem there. Let me oh, I did 2 of them. That's what happened. I wanted to show you something, and that's why I created 2 of them. That's what it was. So that's what it was. Okay, good. When you asked me how to do it, I clicked on that to create another line shell, and it was all screwed up. Fine. Now, let's go up here and insert the pin. Let's do the pin. So insert, new part. Always say no. Zip in. Right-click properties. By the way, if I went too fast over this shelling, I know that, but really you should go and practice on it on a box. You know what I mean. So pin and pin. Okay, let's make it. So on a convenient plane, on that vertical plane, on that plane, I will sketch. Here's a sketch. Sketch. I'm too lazy. Project that circle on it instead of drawing a circle that size. There we are. And then exit, pad it, mirror extent, and go to a particular plane, for example, up to this plane. I think you have to do the other side too, maybe, I'm not sure. Yeah, I think you have to do the other side too. Up to plane. Let me see what happened here. Yeah, so actually double click on this, and on the second tab you go up to the plane, the other plane, and that'll do it. There's the pin. Okay, good. So save it, save everything. Where's that floppy? Right there. Insert the connecting rod. So insert, new part. Say no. Conrod. Right click properties. If I were you, I would sit back, relax, watch this, and go and do it yourself at your leisure with the video in front of you. Don't get stressed out. Conrod. That's really not the purpose of these lectures. Double click. Let's make it. So on that plane, I will sketch. Notice that I'm making them in place because it's easier for me to do it. Okay, so let me project that circle. The conrod is going to, this pin is going to go through that conrod, you know that. So project that circle. There we are. And I don't need this stuff. I can, if you know, I can hide them. Let me do the other one. Let me hide the other one. Hide the pin instead. There, you see that? Okay, and let's do the rest of the connecting rod. Nothing fancy. I mean, connecting rods are a lot more complicated than what I'm doing, obviously. You're going to clean it up in a minute. Terrible. Okay, let's zoom in, make sure everything is symmetric. Maybe this circle, control that circle. You make them concentric. Okay, and I have a feeling that these are symmetric. If not, we'll take this circle, control that axis, we make it coincident. Yeah, and by default, these are probably symmetric now. I don't know. This, control that, control the middle axis, make it symmetric. Yeah, everything looks good. Okay, now we need a little circle here, a little hole here, because the crank is going to go through that. Through the, not the crank, the shaft, I mean, the shaft. Exit, pad it symmetrically by, how about 0.2? Let's see how it looks like. Yeah, it looks good. That looks good. Okay, good. Save it. Save everything. Not like that. Save the assembly. This is the lazy way of doing it. Okay, let's make the shaft. How about that? The shaft. So on this plane, I will. Oh, wait a minute. Let's insert it first. Insert a new part in there. Always say no. And call this thing the crank. Right click, properties, crank. Crank. Double click on it. On a convenient plane, on that vertical plane, I'm using this vertical plane to make all these things, the pin, the connecting rod, you know, I'm going to sketch. Okay, why don't I project that circle? Good. Let's make exit and pad it. Yeah, that's good. And on that face, I will sketch, because I want to do something like this. Okay, I want to do something like that. Okay, so on that face, I will sketch. Hey, you know, we'll clean it up. Don't worry. Okay. There's nothing to clean up here. So, yeah, exit, pad it. That's too much. 0.3. Okay. On this face, I will sketch, because I want to get this guy for you. These guys. This guy, actually. What is that? Oh, this guy. I want to get this guy for you. So let's draw a circle. Yeah, okay, something like this. Exit, exit, pad it. Yeah, let's make it 1. Let me see. Let me make it 2. Okay, now I want exactly the same thing on the other side. No problem. Mirror it. Mirror. Mirror with respect to, what's it saying? With respect to this. There we are. Go up. Save everything. Where is the save? Okay, let's do the what do they call it? The track, or we call this thing what? The block. Okay. So insert, new part. No. Block. And where is it? Part name. There. Block. Okay, let's go make it. Double click. I don't know, I'm going to make it like this. So on that top plate, on that horizontal plate, horizontal plane, yeah, I'll sketch. So I'm going to project that circle. There we are. Exit. Oh, actually, you know what? Let's go back there. I don't want the whole thing, because you can't see what's going on inside. So let me draw a line here and clean it up. Okay, so there's the line. I'm going to trim it. Quick trim. because otherwise you can't see what's happening inside of that track. So get rid of this, get rid of that. Oops. Get rid of the bottom piece. I don't know, one of them. Is that better? Oh, I wanted the line in the other direction. Terrible. No, my line was in the wrong direction. So let me undo all of these. Undo, 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 undo. Okay, the line I wanted vertical, because otherwise I can't see inside of that. Okay, do the same thing. Trim that guy, this guy, that side. Very good. Exit. Okay. I want to do one more thing. Let's go back here. So let me draw something like that. A rectangle. We'll clean it up. We'll clean it up. Okay, like this. Okay, so let me see for a second. Yeah, like that. Let me see for a second. Let me look at the thing that I want to make. Yep. Okay, so I had a bad sketch here. Let's go fix it. Okay, so this is a bad line here. I didn't want this. Let me clean it up. So from here to there, and from here, where is that place? Where is that place that they meet? Right there to there. Vertical. Vertical. There we are. We'll just do another quick trim. So another quick trim, get rid of this. What's it saying? See, this goes. This goes. Why is this thing not going? No problem. Just there's more than one way to skin a cat. Okay, okay, okay. Don't do a quick trim. Just get rid of this. Close that curve. Okay, exit, 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 add it. Okay, so you go up, 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 and there you go down, 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 down. Oh, go down, 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 down. Now look, I can go all the way down and make a hole here and put this thing in it, but I decided not to do that. I decided to do something else, and here's what I've done. Say okay? That is the piece that I was trying to do for you. Now, for these two little rings that belong to that, it's easy. So I go on that face, I will sketch, project that circle. There we are. Exit. Okay, so that's this. Just a second. We need to make a hole here. So let's look at the view from the front. Okay, is this the right one? There. Circle. Now do you see why I said don't worry about doing it with me? It's totally useless to do it like that. Concentric. Excellent. Make this thing a little bit smaller. Exit. Exit. Pad it. Not that much. 0.1. 0.3. I don't know. Good. And you want this thing on the other side? Mirror it. So mirror this thing, this pad, with respect. This is the one. See, underscore means that underline means that this is the one that's acting. Just mirror it with respect to that plane on the other side, not the whole thing. Damn. Actually, let's try again. Mirror. Where's that mirror? With respect to this. It did the top piece too, but it doesn't matter. It's okay. Don't worry about it. It did that thing right here. Okay? So save everything. Okay, let's catch our breath. Are there any questions? Don't worry, you'll get it. All right, so let's fix the track. This is the track or the block. Okay, so anchor that guy. Move everything out of the way so that you can assemble properly. Okay, so let me move this thing here. Move that thing there. Move that thing there. Where's the pin? Well, the pin isn't hiding. I hid it, remember? Right there. Hide and show. Hide and show. Okay, sometimes this doesn't work, so go to the tree. Where is the pin? Pin. Right here. Hide and show. There it is. And zoom out. Okay, let's start putting it together. First thing, I'm going to put the crank in here. So coincidence between that axis and the axis of this little ring here. And the vertical plane of the crank and the vertical plane of the block. So coincidence between the vertical plane of the crank and the vertical plane of the block. We say, okay, update, it's going to go there. Good. Let's put the connecting rod on that shaft. So coincidence between this axis, oops, and the axis of the hole in the connecting rod, and coincidence between the vertical plane of the connecting rod and the one for the shaft. Now, where's the one for the shaft? They're sitting on top of each other because of the way I constructed it. So let's do it from here. The YZ plane, XZ plane of the shaft, not the shaft, what is it called? The crank. This is the con rod and XZ plane of the crank. Update, there we are. Okay, let's put the pin in there. So coincidence between the axis of the pin and the axis of, well, I can do it here. I can do it like, well, let me put the, it really doesn't matter. Let me, yeah, fine. The axis of that, and coincidence, did I do the axis and axis? Can't remember. What did I do? Where are the restraints? This last one was axis to axis. Yeah, that's good. So coincidence between the vertical plane of the pin and the vertical plane of the connecting rod. Con rod. This is a crank. XZ. Say OK. Update. There we are. Now let's put the piston in there. So coincidence between this axis and the axis of the pin. Okay, and coincidence between the vertical plane of the piston and the vertical plane of the pin. Where's that pin? Pin. Right there. And OK, and update. There we are. Now, to check to see if our constraints are okay, you go to move, check this box. See this box? See this box? Check it. And let's rotate it about the axis of the shaft. Okay, look. This is a good sign. There's only one caveat. There's only one problem. It's a good sign, but there's one problem. I'll show you. That's not the problem. Wait. Okay, good. The problem is that if I take the pin and tilt it, if I take the pin, where's that guy? If I take the pin and not the pin, the piston, and rotate it, for example, about this, you see, it's not going to go back where it is. I have to make the axis of the pin and axis of that not the pin, the axis of the piston and the axis of the block coincident. Axis of the piston and the axis of the block. Update. Good. Excellent. So save everything. Okay, let's go ahead and see what happens. So we go to digital markup, DMU kinematics, magic wand, new mechanism, mechanism 1, auto create, say okay. So let's think about it first. You're at the stage where you should tell me what joints you have. Revolute here, revolute there, revolute for the pin and the connecting rod, and a prismatic for this guy, for the piston. So I expect three, I don't know, there's 1, 2, 3, three revolutes and 1 prismatic. Let's check it out.
Professor,
actually, yes.
For the piston head and the block, like the cylindrical covering of it, can we like make a coincidence or a contact between the outside curve of the piston and the inside curve of the block? Is that something we can do?
Did you say contact?
Yeah, I'm saying it like arbitrary. To be honest with you, I really don't know what kind of connection would be able.
That contact, I don't advise you to use it unless you feel more comfortable with it. Now, first of all, right now the pin is only a cylindrical. It's not prismatic because I'm not sure. Let's check it. Don't use contact. My suggestion is don't use contact unless you're absolutely confident it's going to work. Okay, so don't use contact. And we can discuss this thing later on. So look.
Yeah, just a general question.
Yeah. Okay, so let's see now. We have you see that piston and the block. All I did was axis to axis. That's why it came out to be. What is it called? Cylindrical. Okay. Now I can make it prismatic. I can make it prismatic by saying plane, for example, a plane of the piston and a plane of the block to be coincident. And this came out to be prismatic because of what I just told you. Now, the problem is that you have 1 extra degree of freedom. And that 1 extra degree of freedom is because this pin can actually spin about its axis. Because all we did, the pin and the connecting rod, see the pin and the connecting rod? We said axis and axis, and the vertical plane and the vertical plane. That makes this thing a revolute joint, and that's why it can turn. The 2 degree of freedom is mainly because one degree of freedom is because of this pin sitting there loose, it can spin, and the other one is, of course, the crank can turn. So here's what I'm going to do. To fix this, I'm going to take the joint, the revolute between the connecting rod and the pin, which is right here. See that? This? I'm going to delete this. And then make a rigid joint between the pin and the connecting rod. So rigid, we have never used that, right there, between the connecting rod and the pin. There we are. You see, if you don't do this, if you don't prevent the rotation of the pin, it becomes an extra degree of freedom. But we know that you won't let rotation like that happen. Okay, so what are we going to do? We're going to make the crank turn. So where is the crank and the block? Right there. Angle driven, 0 to 360. Say okay. Mechanism can be simulated. Can I do that manually? Yep. What is that? Manually. 1 degree of freedom, rotation of the crank. There we are. There we are. We can make a simulation. Cartoon, no physics. Insert, rewind, anything but one. This is the same slider crank mechanism that I did for you. It's just that it's fancier. And you can specify the speed of the crank and then find out what is the acceleration of the block, not the block, the piston, because those acceleration are needed to do stress analysis of it in a different course, not in my course. You're done with stress analysis here. So I don't want to do physics anymore. I mean, I don't want to do the